Hey everybody, this is Larry. This is doing this week's Leetcode Weekly Contest 184. Um, hope you enjoy the stream as I do it live. Hit the like button, hit the subscribe button, leave your comments. How did you do today? I hope you did well. Explain the problem at the end, so definitely look out for links below to skip ahead. And I also the other Larry Head will talk about his thought process as we go through this. Um, yeah, without further ado, there's about 10 seconds left, so just in time for you to wish me a little bit good luck. Hopefully, I won't need it that much, but you could always have a little bit of good luck. So I'm excited. All right, and here we go. And here we go. Yeah. Problem one: string matching in an array. So this one I talk about. So as soon as I saw it, I was like, okay, this looks pretty straightforward. Let's think about constraints, right? And I was trying to think about what's the most brute force way I can get away with. And actually, because of the constraint, because n is equals to 100 and each string length is up to 30, I could be really brute force with this problem. I wouldn't recommend it on an interview though, but and I think the only thing that I was a little bit worried about was like, can I do this word versus word is not equal to word two thing? And then one of the constraints, if you look carefully, that is guaranteed that the words are unique. So that means if the two words are the same, that means they're the same index. So I didn't have to double check. Otherwise, I was going to write something special for that. But otherwise, yeah, still a little scary. But it was like, wow, the new uh, the new Leetcode machines are fast, and I'm happy about that. And I submitted it, and that was in 1 minute 7 seconds. Um, okay, second problem. Uh, Queries on a permutation with key. So this one could really potentially be tricky, and uh, there are definitely ways to think about it, uh, but yeah, but definitely because of the constraints of the problem, which at some point he'll scroll down because I think I'm still reading the problem at this point. Um, but yeah, once you read the constraint of the problem, like okay, m is equal to 10 to the third, which is 1,000, but so like m squared should be good enough, and that's what I usually end up doing, as you can see. Yeah, and I even did probably a little bit in retrospect and even probably at the time. Actually, I think I was thinking about it at the time, but I thought this was a little bit less error prone. Um, it's which is that I actually on every query I re-indexed on a hash table, which is unnecessary because you could just do a linear search, because putting everything in a hash table is the same as doing a linear search. Um, so I think, so yeah, so a challenge posed was if you're watching this now and you did it the n square way like I did, that's great. But can you do it better than n square? There's definitely, so yeah, pay attention a little bit to the constraints, and you could come up with a way to solve this that is not n square. Leave it in the comments. I'll give you mad props and my respect if you could get it quickly. Um, but it is with an algorithm that I would say it's rather popular these days in competitive programming. Um, and actually, to be honest, if it was Code Force and it was like on a slightly harder problem, because this is um, Q2 on Leetcode Contest. So I was definitely, even when I was thinking about it, I was like, n square feels a little slow. Can I do a little faster? But looking at the constraints, I didn't think about it. But I was like, this is actually, you could easily do this in, let's just say n log n. And this would be a very good standard quote unquote algorithm problem. But, uh, but yeah. But yeah, I even as you kind of see me coding, I actually coded this really inefficiently. Um, so I was a little bit scared, to be honest. But one thing is that this problem is a little bit easier to test. I have an off by one, or um, the array needs to be one index, but I created a 0, 1, which actually cost me a couple of seconds. Now that I think about it, I ended up spending about 4 minutes and 47 seconds on this problem. Um, but I mean, some of this is deliberate in that I am trying to be a little bit careful. The last couple of weeks, I've been submitting things very quickly, but then getting wrong answers, even though they're done really quickly and mostly right. But I had some like either off by one or missed an edge case that was very obvious. So it's about four. So I spent, yeah. So this was, I spent a second or two here. I mean, after this, I think on a normal day, or like on a day where I feel really good about myself, I probably would have submitted. But I really wanted. I was like, okay, this is actually easy to test. Um, so let's at least like try a little bit. And that's what I kind of spent about, let's just say 40 seconds on, which is not maybe not that much in concept, but considering people finish this problem, this contest in 10 minutes, 40 seconds is, you know, it's not nothing. My only thing here was just to kind of look at the running time, because I knew this was linear in terms of queries. So seeing that it was only 84 milliseconds, I was like, okay, that'll be good enough for me. Like I think if it was like in the 200-300 millisecond thing, then I'll be like, okay, I need to kind of test the bigger cases and double check a little bit. But given that this wasn't the case, yeah, cool. So yeah, so problem 3, HTML entity parser. Yeah, I don't quite understand this problem in the sense that like let's see how long I took on this one. I took about 3 minutes, but some of that is that I was actually doubting myself because I thought this was a little bit easy. Like like okay, I was a little bit lazy in that I just used library, but even not doing that, if I just did a linear search on each of the special strings, or you could write it to do in parallel, but it does the same number of operations. Um, like that should be fast enough, which I was very surprised for a Q3 of Leetcode. Usually it's a little bit more tricky than this. So I was a little bit doubting myself. So and you can kind of see that, let's see, just look at my timings. I spent about a minute just typing this out, about a minute and a half, and I spent 3 minutes about submission on this problem total. So I didn't do that much work. I saw that the n, where n is the length of the string, is about 100,000, and if you want to do some hand wavy math on how long it takes, it's just the sum of all those special escape characters. So like, and it should be fast enough. And the other thing is that in Python and maybe other languages as well, I could be wrong in this one actually, but I remember being that the replace function and some string functions are very optimized. So I kind of did have a little bit of doubt on this one. I did run code, and I could have, and on my more arrogant day, I may have submitted it. But today, like I said, I am making an effort to be a little bit deliberate. And yeah, and a little bit the quote thing also threw me off a little bit. But I was just double checking that I don't miss something silly, because in the past couple of weeks, I've submitted stuff where it didn't pass the example, but I misread the example thinking that it was right. So I was like trying to be a little bit careful this time. I spent 40 seconds there too. So there's definitely time I could have spent better, but I'm not going to complain about it because, like I said, if you have a typo that costs you 5 minutes on a contest that people solve in 10 to 15 minutes, then then and as you can kind of see, I spent a little bit of time waiting, but yeah, but Q4, number of ways to paint n times 3 grid. So immediately I thought I knew how to solve this. I saw the mod first and I was like, okay, I keep on messing up the mod, so let me handle this now. And there was also a contest where I put in the mod variable on top on line 3, but then I forgot to add it to the last return statement. Uh, so you could see me that even though I know that answer is not declared, I was like, okay, just leave it as a placeholder so that future Larry will remember. But I actually misread this problem initially, in that I thought it was one linear, like 1 by n, like a linear array, and you have to color them in such that no two adjacent colors are the same. Um, but but I actually misread that, so you could kind of see me going that way for a couple of minutes. Um, but yeah, so as you can see, I was trying to figure out how to do. I mean, I was just setting up the templates a little bit and doing the mods, but I would just figure out like, okay, the two colors that are adjacent. I just have to like, and this is like in theory, if that was the problem, this is actually already mostly done. I just need to, and I was like, okay, just -1's fine. I have to do if color is if and then I was going to do with color is not equal to x, you do the add, but then after I read this, I was like, wait a second, that's not the problem. Uh, so I read this again just to make sure. Well, you read it right this time. I was like, 12. How do you get 12 for one? And then, okay, after this, I was like, okay. So a standard technique that would come in handy in other languages is that, and you'll kind of see me beginning to write that, is encoding uh, encoding dimensions into one dimension. Not for it's not for one-time reasons. It's just for just easier to type because when you cache it and the array, like you have to type more arrays and stuff like that. It's not a big deal, and I don't think it matters that much to be honest. So maybe I made that up. But yeah, after that I was like, okay, this at most 3 to the 3 each case. So this is not the correct math per se, but at most 3 to the 3 so it's 27 times 5,000, which is n. Like that should be way fast enough if you do memorization. Um, and you can see me try to convert it to base 3 with the three numbers, one for each column. Um, yeah, corrected so that you don't count the first one because that's what we're doing. I also made that mistake in one recent contest. I don't know why, but I'm actually testing compiling here. I also didn't notice that I have a typo, obviously, so maybe the compile was necessary anyway. But I was just not wait. I think, to be honest, a little bit of this, what I'm doing right now, is a little bit procrastinating. I was like, okay, while I'm doing this compiling test, I'm thinking, um, can this possibly be right? Like, is it this easy? I think is what I'm thinking, or like, is there any random tricks that I'm thinking about or need to think about? So that's what I'm thinking about while I'm sending the code for compile. And also, I'm expecting the answer to be 12. And also from this, you can notice that um, there's only 12, right? And that's at most because that doesn't include the previous column or previous row and matching different columns. So actually, there's only ones about at worst 12 times 5,000. You could get tighter bounds than that, but that's how I was thinking about it. And as you kind of see, um, I was trying to as you kind of see, I was like, okay, I could do these conversions from base 2 through from base 3 to base 3 or back and forth. But I was like, actually, LLU cache does this for me. Just change the dimension, add those to dimensions, and that's kind of what you see me do here. Yeah. Yeah. So I coded up, I looked at, and I just double checked the 5,000 case. And I knew that was going to be the worst case, so I submit, and there we go. Also, just double checking, but.
Okay.
Bye-bye. Not a kind of an easy contest, and people show it. But I still think I finished in the top 10, so okay, a little bit of celebration. I mean, I did very well, obviously, even though I took my time a little bit on the last one. Oh, okay. So actually, I might not finish in the top 10 because of the Chinese server, but they always merge a little bit later. But I knew that I did really fast on this one in general, so yeah, I even was a little bit slow on the last one because I just really want to make sure I get it right. Because I know that if I had added 5 minutes, then like I'd rather spend extra time to not waste the 5 or not get the 5 minutes penalty. Yeah, so that's kind of my yeah, that's kind of my thought. Let's go over the problems real quick. Let's go over the solutions. Yeah, so the first one, string matching in an array. So this one, I very much looked at the constraints. I took about 1 minute 7 seconds, but yeah, it was all about constraints. And I think, and the only tricky, so I did a brute force. I did a for every word, so n square number of combinations, and then I do a very naive. So it's an n cube algorithm. Saying that n is equals to 100, that's okay. So it's n squared times the length of the word. So n squared times 30. So 100 squared times 30 was okay. And I think the only case that I was thinking about was that if they are equal to each other, then like how do you handle it? Well, one of the constraints guarantees that it won't happen. So I was able to just do a very lazy, naive way of doing it, and yeah, and that was good enough. I mean, it was a 1 minute solution, so yeah. So queries on a permutation with key, I spent about 4 minutes 47 seconds on this one. So again, I think this was an exercise in just looking at the constraints. I saw that m is equal to 1,000, so I did a very naive thing again, where I just simulate the problem, right? I literally create an array of size m up to m, and then for each of the queries, which is also m of them, I just literally, I keep I don't even need this hash table, to be honest. I knew that when I was doing it, but I was like, I worry about it, because you just have to find the index. So whenever x is equal to h or x is equal to q, you could even terminate and early terminate and then just do the things. But I was like, okay, let's try it. And then I tried the 5,000 and m equals to 5,000 case, and it was fast enough. So I did spend a little bit, I was a little bit slow because I test that case, because I did it a little bit, not suboptimal, but good enough for the problem. And that's n is equal to, or m is equal to 1,000. So this is m squared, and m squared is fast enough for 1,000,000. I just wanted to make sure, so I did check that a little bit. HTML entity parser. So I don't know, because in real HTML entity parsing, there's like more weird cases, I think. And I took about 3 minutes this one, and even then I took a little bit of time to kind of double check my answers, because one is the quote on the if you look at the results. Wow, it was really fast. They're like weird quotes on the string, so I was like double checking just to make sure I was right. So I was spent a little bit of time there, but otherwise it was very. I mean, this is a little bit ridiculous, to be honest. I did a way. Yeah, I mean, again, this is another constraint analysis, if you want to call it that. So the length of the text is 10 to the fifth, which is 100,000. And each of these replace levels is one. Well, in Python anyway, this is very optimized, but you're only going to, do like 5 characters at a time. So this is a little bit about the length, the sum of all the lengths. So given that this is 100,000, you have, what is this, like 4 or 5 characters. So like 5 or 6 worth of characters is 30. So it's like about 3 million operations, which is probably a little bit cutting it close, to be honest. But again, it's a little bit optimized, so it's not exactly on the Python usual time frame in my head. But obviously a little bit, like I could have, like this could have been easy, and I could have been like, okay, and maybe I would have gotten a little bit faster, to be honest, because I was second guessing myself because it was so because it was the third problem. Right? The third problem, I second guessed myself just because I was like, I don't know if that was right. But it turned out to be okay. Yeah, the last problem. Well, first is I misread it. I thought I mean, even though it is in the name of the title, so I have no excuse of misreading it. But I still misread the. I just thought it was just one line of n items, where 2 consecutive ones cannot be next to n, which is also a common problem that I almost solved here. But what I but it's but n is about 5,000, so I was very prepared to do something like very brute forcey brute force in a dynamic programming kind of way. And here you can I was actually thinking of, and you may have seen it while I was coding, was that I was trying to do this by encoding x, y, and z in one character, because 3 to the cube is 27, so it's definitely 27 times 5,000 is way fast, right? But then I was like, oh, actually, I'm using LRU cache anyway, so might as well just break them down so that's easier to write. So then I don't have to convert it back and forth. I just had to write, the previous one, and after that, it's just all if statements. Like if the x, I mean, I called up x, y, z for one of the 3 columns, which is, if x is not equal to previous x, which is an obvious condition. With y is not equal to the previous y, which is also an obvious condition. And then c is not equal to the previous z, then also, another condition. And also just double checking that they don't, the adjacent ones are not the same. There are 12 combinations, and so for each index, so once in roughly 5,000 times 12 times. I mean, and maybe even, and technically less because of additional constraints, right? Because it's 3 for that reason. So yeah, and I think I was a little bit careful because I keep on forgetting the mods. So you saw me probably type the mods in the beginning, so that was kind of good in my end. But otherwise, this is a very straightforward combinatorial problem, which is just try every possibility one level at a time. So overall, I mean, you can't complain when you get to the top 10. So I was very happy about that. I probably could be a little bit faster, but like, it's probably not worth, or almost definitely not worth me being, 40 seconds faster if it means a way higher probability of, getting it wrong. So, and then adding 5 minutes. So if I add 5 minutes, let me refresh this. And now a lot of people are done. So if I add 5 minutes, I wouldn't even be in the top 25. So I think definitely my deliberateness paid off here. My second top 10 finish. Thanks for watching, and stay tuned for the very short commentary. Or, well, actually, I guess you already watched it. But yeah, thanks for all your good luck, and thanks for your support. Hit the like button, hit the subscribe button, and I'll see y'all next week.